Hi guys, in this video I am going to explain about the DES encryption, and if you are visiting my channel for the first time, please do like and subscribe. So what is DES? DES stands for Data Encryption Standard, and it is a type of block cipher because in this the data is encrypted in the form of blocks rather than bit by bit. And it is also a symmetric cipher because both the sender and receiver will use the same keys. In DES, the size of plain text which is used is equal to 64 bits, and it encrypts data in blocks of 64 bits rather than bit by bit. And what DES does is it goes through 16 fiestal rounds in order to encrypt the data. And so when we see the steps for the encryption, we can say that it has 4 steps. First is the initial permutation. And what happens in initial permutation is, for example, you have the input data as 0, 1, 2. And you know that after trying various permutations and combinations, we have so many ways in which we can represent these 3 bits. So in similar way, when we get the 64-bit input for the DES, then we rearrange it in such a way that this way will be defined. For example, we can change the positions of bits in such a way. Here we can say that the 11th bit of the input should be positioned at the first place, and the second bit of the input should be positioned at the third place, and 64th bit should be positioned at 5th place, and this goes on and on until all the bits are rearranged. And so this is what happens in initial permutation. And then after that we go through 16 rounds, that is 16 fiestal rounds, and then swapping takes place, that is left right swap. And then we have the final permutation, which is also called as inverse initial permutation. So this happens in the same way which I have told here. Now let us see that what are these 16 rounds. So what happens is, we give the plain text, and then after initial permutation it goes to the round 1. Here the arrows are missing, but after initial permutation it goes to the round 1, and we have a 56-bit key, and which then gets processed to 48 bits, and this produces different keys for each round. You need to remember that in all the 16 rounds, the key which is provided to each round will be totally different. So this after going to the initial permutation, it goes to round 1, then round 2, and then round 3, and so on till round 16. And then after the final permutation, we get the 64-bit ciphertext. And if we want to see that what happens in a fiestal round, we can see here. So this is what I have shown here is the round 1. So here we have a 64-bit data as input, and then it is divided equally into 32 bits, and this can be called as LE0 and this can be called as RE0. And in this what happens is, the 32 bits at the right side will be passed to a function along with a 48-bit key, and this key 1 is the key which is given to the round 1 here. So here you can see that we are providing 48 bits key and 32 bits of data, and the output produced is 32 bit. So what happens in this function, I'll tell you later. And so once the 32 bit is produced, we take the input of this 32 bits, and this is XORed with the 32 bit output which we get from the function, and the output of this and the output or result of this is then made as RE1. And in order to find out the LE1, we just take the 32 bits from the upper round and place it here. So this becomes the input for the second round. And in similar way, this LE1 will be given as input along with the 32 bits from the function to the XOR, and this will form the right part. and similarly the right part of the second round will be the left part of the third round. So this is what happens in the fiestal rounds. So 16 rounds of this will take place, and finally 64-bit ciphertext will be produced. And here each keys are different. Now we are talking about the function which we have used here. So what happens in this function is, we know that we get 32 bits of input. So this 32 bits input is this part which we are getting, and this is the key 1 of 48 bits which we are giving here. So now what happens is that 32-bit input goes through the expansion box, and which then produces the output as 48 bits. So now since we have to perform the XOR, we now have key also 48 bits, and then the output of this also has 48 bits. So now we can perform the XOR, which gives 48 bits as the output, and this 48 bits is then passed through SBoxes. So here there are 8 SBoxes, and this will compress this 48 bit into 32 bit, which is then passed through one more P box, and which produces the 32 bits as the output. Here what I'm showing is the function for S1 for the round 1. This is because the key which is provided is for key 1. Similarly, for each round this key value will change, and in this SBox, each SBox takes 6 bits as the input and gives 4 bits as the output. That's why the 48 bits get converted into 32 bits. Now let us see that what happens in the expansion box. So if we go to the expansion box, let us see. For example, we have taken a random input of 32 bits here. So this is my input from here to here, and it is of 32 bits. So now I'm showing that how it gets converted into 48 bits. So in this what happens is, for now just ignore this part. Now we'll see that how this changes into 6 bits, and I have already told that this 32 bits is divided into block of 4 bits each. So once it is divided into 4 bits, you can directly take this 4 bits and put it here, and after that you need to fill the first and the last bits for the 6 bits box. And the first bit of this is the last bit of the block previous to the block which we are seeing. So if we want to convert this into 6 bit, then the first bit of this block will be the last bit of its previous block. So here we'll get 0, and similarly for the last bit of this block, we'll take the first bit of the next block. So here 1 is there, so we'll write 1. And similarly for 1010, we'll put the 4 places as it is, and then go to the previous block and see the last bit, and this last bit will be the first bit for this block. And similarly this goes on until the entire input is finished. And now we need to see how the first 4 bit or the last 4 bit is encrypted. So for that we assume that these bits are continuous, like in a circular way, or how Earth is connected, or is spherical. So here let us consider, let us encrypt this, let us convert this 0110 into 6 bits. So now we'll write 0110 as it is, and in order to find the previous block, we'll take the last block of the input. So now I'll write 0110 here, and for the first bit of this block, I'll take the last bit of its previous block, that is the last one, and here 0 will be put. And similarly for the last bit, I'll take the block next to it, and the first bit of it will be put here. So thus each 4 bit is converted into 6 bits, and this is the way in which 32 bits will go to the expansion box, and the output will be 48 bits. and these can be easily XORed with the 48-bit key, which we have seen in this function. So here what happens I have shown. Now let us see what happens in the SBoxes. So this is the SBox. In this we have 48-bit as input, and for each SBox what we'll do is we'll give 6 bits as the input. So this way the 48 bits will be covered, and each SBox will produce 4-bit output. So since each 6-bit will produce 4-bit output, we have 4 into 8 equal to 32-bit as the output. So now let us see that how we convert the 6-bit into 4-bit. So for example, I am taking the 6-bit input for SBox as 0 1 0 1 0 1. So first what we'll do is we'll take the first bit and the last bit, and this together will form the row. So 0 1 when converted into decimal is 1. So it means first row. And the rest 4 bits in between will convert it into a decimal, and this will be 10. And this represents the 10th column. So now this is the table for SBox 1. So when we'll see, we can see that this is the first row and the 10th column. So here the number in this table is 2 for this corresponding value. So since we have to produce the 4-bit output, we'll convert this into 4-bit binary, so which is 0 0 1 0. Thus the 6-bit is converted into 4 bits. So here in each SBox, this goes on and then produces 32-bit, and this table will be different for each SBox. So this is the way in which this is done. I'll also cover the key generation for STES, so stay tuned. Thanks for watching my video. Please do subscribe.